This is Ishnai Ciarfox, and welcome to my stream. I'm running a bit behind on everything, but this is our monthly check this out science stream. So I have a few articles to share. Hi Haru, how are you? I have a cat that wants to visit. Num num num. Alright. Live science, by the way. Links are above. This is James Webb's telescope finds a vanishing galaxy from the dawn of the universe. I apologize ahead of time if I fail at saying things. Actually showing screen that I want it to? Yes, yes it is. Interrupt, but you're making it happen. Well, it sounds absolutely excellent. Okay, I just happened to see this one right here that has nothing to do with what we're gonna, but I'm putting that over here. Be the general. Because I have it actually kind of put into order of different information. Alright. The earliest galaxy, AZT-ECC71, is so far away it keeps disappearing from telescopes and observations. A new study by the James Webb Space Telescope finally pins it down. Move, cat. This is the image from the early universe. It's hardly what you call dazzling. You're looking at a very blurry, highly dust-obscured resident of the cosmos whose name only is a string of numbers and letters. It even sits at a distance so far from the Earth that it slips in and out of watchful eyes of various telescopes. The image captured by the powerful James Webb Space Telescopes spotlights the galaxy AZTECC71. But what's striking here is that we're seeing the galaxy the way it was just 900 million years after the Big Bang. That's when the universe was turning on its very first stars, absolute eons before our system was born. The telescope's view of this galaxy as a hazy speck of lights is a far cry from the many other glorious images of galaxies and galaxy clusters in its repertoire. However, even this smudge, holds important lessons for our understanding of the early universe. The fact that even something that extreme is barely visible in the most sensitive imaging from our newest telescope is so exciting to me. Study author Jed McKinney of the University of Texas at Austin said in a statement, "It's potentially telling us there's a whole population of galaxies that have been hiding from us. This could mean that the early universe was much dustier than previously thought," scientists say, shedding a little more light on how it evolved since the Big Bang occurred roughly 13.8 billion years ago. AZTECC71 was first spotted as an incomprehensible blob of light by the James Clerk Maxwell Telescope in Hawaii. Later, it was also seen by the Alma Radio Telescope in Chile. However, it seemed to vanish in images taken by the Hubble Space Telescope. "This thing's a real monster," said McKinney. "Even though it looks like a little blob, it's actually forming hundreds of new stars every year." As part of an international effort to map the earliest structures of the universe in a chunk of the sky the size of 3 full moons as seen from Earth, McKinney and his colleagues looked for the galaxy in the data collected by the JWST. This observatory's powerful and unprecedented infrared eye is capable of peering into thick dust clouds prevalent in the early universe. Words! Before the JWST, these galaxies were close to impossible to seek out. The light from the birthing stars sitting deep within dust-shrouded galaxies was absorbed in optical wavelengths by the dust itself and re-emitted at faint, longer wavelengths than the JWST can pick up on. 1 in 5 such galaxies have remained invisible to the Hubble, forming a group of what astronomers call the Hubble Dark Galaxies. That means our understanding of the history of galaxy evolution is biased because we're only seeing the unobscured, less dusty galaxies, said Miss McKinney. In the near future, McKinney and his team plan to uncover more faint, hidden galaxies with the JWST data, which can only stare back into the furthest reaches of the universe. Which can not only stare back into the farthest reaches of the universe, but it can also pierce the thickest of dusty veils. James Webb Telescope. Yeah, see, I put them into sections. This is mostly about James Webb Telescope. Wow! And when was this made? Oh, April 29th, so it's recent. James Webb turns to examine planets showing potential signs of life. NASA made a huge splash in September when it announced that the James Webb Space Telescope had spotted potential life signs on an exoplanet dubbed K2-18b in the form of dimethyl sulfide, a gas that's produced exclusively by life forms on Earth. Now the telescope has turned its full attention towards the distant ocean-covered world. On Friday, it took another 8-hour-long peek to further investigate the tantalizing findings, as the Times reports. An exciting step on our effort to probe what has been described as one of the most promising known locations for extraterrestrial life. Planck call. The ramifications of the discovery of DMS on the exoplanet are considerable. The gas, as per NASA, is only produced by life here on Earth, with the majority of it being accounted for by phytoplankton and marine environments. Whether that holds true on K2-18b is anything but certain, which is particularly frustrating because the exoplanet is located a whopping 124 light years away, making it practically impossible to visit and investigate firsthand. Nonetheless, excitement has been steadily growing. The JWST's spectrometer readings found that methane and carbon dioxide were abundant, which led scientists to conclude that the sub-Neptune planet was likely covered in a massive oceans, hundreds of miles deep, and a hydrogen-rich atmosphere. That right away said you need to have an ocean, Cambridge astrophysicist. Oh, I'm so sorry for slaughtering this. Niku Madhosahan, lead of the ongoing research, told the Times, "This is the first time we've detected methane in a small planet ever. It solved a more than decade-long mystery, literally called the missing methane problem." Meanwhile, confirming the presence of DMS could revolutionize scientific history, he argued. But before we do that, they have much to do. The plan is planning to spend the next 10 months pouring... Hari har har. Next 10 months pouring over the results of the James Webb's latest observations. Early results could reveal as soon as... could be revealed in as soon as 4 to 6 months from now, according to the report. If we do detect DMS, it does put it basically on the top for potential signs of habitability. Ugh. James Webb Space Telescope may have found the oldest black hole in the universe. it has to. What they mean by missing methane is it comes down to uninhabitable planets. There has to be a certain balance, and a lot of it was missing that methane part. Hardy har har. Bad joke, bad. I mean, that's more of a like middle school type joke. I mean, that's still a child, but that's also considered a preteen. I know, right? Teasing, teasing. Um, it just comes down to the significant amount of methane is produced by microbes, and I'm guessing it just comes down to why cat are you walking across that again? Therefore, if the methane is created by, okay, here, let me pull this up. The case and context for atmospheric methane as an exoplanet biosignature. Astronomers will soon begin searching for biosignatures and atmospheric gases or surface features produced by life on potentially habitable planets. Since methane is the only biosignature that the James Webb Space Telescope can readily detect in terrestrial atmospheres, it is imperative to understand methane biosignatures to contextualize upcoming observations. We explore the necessary planetary context for methane. Yeah, see, abundant sources of methane could result in false positive scenarios. So basically, you have to take a few things into account for it, rather than just one thing. If life is abundant in the universe, then with the correct planetary context, atmospheric methane may be first detectable indication of life beyond Earth. Well, I mean, they're not saying it's 100%. They're using it as a sign to pay closer attention to it. And then rule out all other variables with it. Methane has been proposed as an exoplanet biosignature. Imminent observations with the telescope may enable methane detections on potentially habitable exoplanets. So it is essentially to assess what a planetary context methane is In what planetary context methane is a compelling biosignature? Methane's short photochemical lifetime in terrestrial planet atmospheres implies abundant methane requires large replenishment fluxes. While methane can be produced by a variety of abiotic mechanisms such as outgassing, serpentizing reactions, and impacts, we argue that in contrast to an Earth-like bioatmosphere, known abiotic processes cannot easily generate atmospheres rich in CH4 and CO2, with limited CO2 due to the strong redox disequilibrium between CH4 and CO2. Methane is thus more likely to be biogenic for planets with a terrestrial bulk density, high mean molecular weight, and anoxic atmosphere, and an old host star. An abundance of CH4 that implies surface fluctuations exceed what could be supplied by an abiotic processes, and a atmosphere CO2 that's comparable with little CO. So basically, that's what they're saying. Is well, not only that, the thing is, if you're looking at the ground that has no water on it, are you going to immediately say, oh, that must have a fish on it? Because it's on Earth, and Earth. But it says right here, known. Well, what it's saying here is we do know antibiotic processes, which you mentioned about Venus and stuff, but it says it cannot easily generate atmospheres rich in CH4. And CH4, of course, is methane. Well, it says something about due to the strong redox It says with other chemical compounds presented only trace amounts. Carbon dioxide, nitrogen. This is Venus. Not even pH4 isn't even showing up in the general absorption. Oxide, yeah, there's here. Next phase of exoplanet science will focus on characterizing exoplanet atmospheres, including those of potentially habitable planets. There's something I want to show you when we get to it. Because they actually have found water and stuff on there, and there's a possibility of stuff with Mars. Then it's probably, if it has bacterial life, that shows that it is being able to be habitable, just not by us, but it's being able to be habitable. Ugh, that word. Ah. This also has to do probably with the base equipment that they have on the telescope. Only fits so much stuff in there. On terrestrial planets, which are focus of this study, require significant methane surface flux to sustain the hot atmospheric abundances. On Earth, life sustains large methane surface fluxes, and so methane has long been regarded as a potential biosignature gas for terrestrial exoplanets. Previous studies have considered a biotic methane production, methane biosignatures in the context of chemical disequilibrium, and the prospects for remote detection of methane on terrestrial atmospheres. During the Archean eon, 4 to 2.5 GA, Earth's atmosphere likely had high methane abundance, estimated 10 to the second power to 10 to the fourth power times modern, due to life methogenesis. Methane is thus not a hypothetical biosignature because we know of an inhabited terrestrial planet with detectable levels of biogenic methane, the Archean Earth. However, methane is sometimes dismissed as irredeemably ambiguous due to its ubiquity in planetary environments and potentials for non-biological production. Additional work is clearly needed to understand the methane biosignatures and their false positives within different planetary contexts. basically, if you have a tool to, you know, shift things out of a big garbage, you wait until you have the right side of the right size of shift that you need to get what you're looking for. Science isn't about knowing the exact answer exactly right away. Also, most scientific papers are not 100% correct. It's usually what you do is you have studies, and then you have studies that study the study, and then you have studies that are done the same way as the old studies, and then you compile the information from there. It's not an immediate thing of having all the answers immediately. This is just one paper. A paper. Usually a paper is very dedicated to one statement. This isn't coming from NASA. This is coming from Princeton. And NASA, as somebody whose father works at NASA, you think NASA is a conglomerate of a bunch of stuff? No, 90% of them are subcontracted out. Trust me on this. Some of them do have NASA on them, but no, a lot of them are like, you wouldn't believe the stuff that NASA says they do when they don't. I mean, think about it for a second. You know how that Titan submersible said that it had NASA, you know, inspections on it, when it sure as hell didn't? Or not NASA, but at like cooperation with NASA. When they didn't. So anything you should take. And not only that, NASA now is pretty much hands out when it comes to the space business. Like the next space station isn't even going to be run by NASA at all. It's going to be a private company. So but the thing with theories is they're theories, they're not laws. I mean, hell, we tried to make Newton's law way back when, make Newton's law, you know, the thing, and then it turns out no, it is not. And then the E equals mc squared was a thing until it turned out till it's not. So it's just the whole idea is take everything kind of with a grain of salt with understanding it, and this is the best way we currently have the ability to find exoplanets. It's not the best way, it is a way. Well, why they write so much is to prove where their viewpoint is coming from on what their theory is. It's also pulling up data that says, this is why I think my theory is correct, and here's the data for it. I know, right? Like, Newton's law used to be the thing, and then it's not the thing, and then some of it is the thing, or... Yeah. So, anything that is made into a law when it comes to science, yeah. We just don't know. But a lot of these articles, especially that one, is just arguing why they think that this might work as a way of... And here, it even said that the article has been corrected and updated with a different article that shows data. So, I mean, they're continuously correcting it. Oh, yeah. Well, I mean, one of the articles I did last month that I'm slowly posting on my YouTube talked about how they thought that they had the Hubble constant in telling how old universe was and how quickly it was expanding, but then they realized past a certain point it doesn't actually work, and so they had to like have a medium ground between that and a different way of measuring. Well, no, it wasn't the measurements, it was the calculations itself on how it was calculated out. So but it's just... Science is science. If you sit there and say something's a fact 100% of the time, you're wrong. There might be more... There's more probability than there is less probability on some things, but to sit there and say 100%, no. The spectrum. I know, it's kind of like you have enough, I guess, chutzpah to basically sit on this theory that everybody is showing is wrong and, you know, dig your heels into the ground. What if you use that kind of energy and determination to something better? I bet we have a lot of mysteries that might have been solved with that level of dedication. The James Webb Space Telescope has spotted the oldest black hole ever seen, an ancient monster with a mass of 1.6 million suns lurking 13 billion years in the universe's past. The James Webb Space Telescope, whose cameras enable it to look back in time to our universe's beginning, yeah, spotted the supermassive black hole at the center of the infant galaxies, Z, excuse me, 1 1, just 44 million years after the universe began. And the space-time rupture isn't alone. It's one of countless black holes that gorged themselves to terrifying scales back in the cosmic dawn. The period of about 100 million years after the Big Bang, when the universe began glowing for a billion years. How the cosmic whirlpools ballooned in scale so rapidly after the universe began isn't clear, but looking for an answer could help explain how today's supermassive black holes, which anchor entire galaxies including our Milky Way, grew to such mind-boggling sizes. The researchers published their findings earlier this year to the preprint database ARXIV, but the research has not been peer-reviewed. I'm guessing some of that is a reference to maybe in Roman numerals, but I can't quite place it right now. Black holes in the early universe can't grow quietly and gently as many black holes do in the present-day universe. Lead author Roberto Maiolino, a professor of astrophysics at the University of Cambridge, told Live Science they must experience some particular birth or formation and some peculiar growth. Closer to the present day, astronomers believe black holes are born from the collapse of giant stars. But however they come to be, they grow by ceaselessly gorging on gas, dust, stars, and other black holes. As they feast, friction causes the material spiraling into the black hole's maws to heat up, and they emit light that can be detected by telescopes, turning them into so-called active galactic nuclei. The most extreme AGN are quasars, supermassive black holes that are billions of times heavier than the sun and shed their gaseous cocoons with light blasts trillions of times more luminous than the brightest stars. Because light travels at a fixed speed through vacuum of space, the deeper the scientists look into the universe, the more remote light they intercept and the further back in time they see. To spot the black hole in the new study, the astronomers scanned the sky with 2 infrared cameras. The JWST's mid-infrared instrument and near-infrared camera, and used the camera's built-in spectrographs to break down the light into its components' frequencies. By deconstructing these faint glimmers from the universe's earliest years, they found an unexpected spike among the frequencies contained within the light. A key sign that the hot material around a black hole was beaming out faint traces of light across the universe. Oh yeah, they've been, especially since the Webb telescope has been put out there, there have been pretty good leaps with stuff. So, at least what I've seen, because I used to work at a space museum, and if it says my age, it was before they hadn't sent up the Webb telescope yet. And the news that we were getting from when it came to this kind of stuff was very, very slim. But then again, I'm gonna point out there's also been a big boom in actually building telescopes in different locations too. And also because now there's 2 telescopes like the Webb and the Hubble working together can also, you know, get more tests done to some degree. Or compare data most popular explanations for how these early black holes grew so fast are that they formed from a sudden collapse of giant gas clouds, or they came from many mergers between clumps of stars and black holes. Nonetheless, astronomers haven't ruled out some of these black holes might have been seeded by the hypothesized primordial black hole, thought to be created moments after, and in some theories even before, the universe began. Oh, definitely. I mean, there's still like announcements about new galaxies or stuff that they found that were so far back in time. Of course, the last article mentioned about the the first article, excuse me, mentioned about being unable to see into the the dust clouds to see about the stars on the galaxies in there, but now they kind of can with Webb. Well, far better than they could before. It's not so clear that direct collapse is the only way to make a black hole, because you need some special circumstances for it to happen, Lino said. You need to be a pristine cloud yet to be enriched by heavy elements made by the first stars, and one that is fairly massive, from 10,000 up to 1 million solar masses. To prevent such a cloud from cooling too quickly and collapsing into massive stars first, it also must be beamed by an ultraviolet light, likely from a nearby galaxy or black hole. So you need this peculiar condition where the clouds is not getting enriched by absorbing exploding star material, but also is next to another galaxy which is producing a lot of photons. So we're not necessarily looking for a single scenario, but actually two or more of them could be at play. Okay, I'm not sure if this is bacteria or not. I just found it interesting. Hundreds of black spiders spotted in mysterious Incan city on Mars in new satellite photos. Every spring, creepy black spiders sprout up on Mars as buried carbon dioxide gas releases dusty geysers of gas. The new ESA images show the phenomenon has begun in the strange Incan city. I mean, they're not spiders. Arachnophobias need no fear. That's what it says literally in the article. A new European Space Agency image of the Martian spiders actually shows seasonal eruptions of carbon dioxide gas on the red planet. I respect spiders until they are on me. Then the spider has two choices. If it continues to crawl towards my face, I will absolutely use my hand to throw it halfway across the room. If it's slow and I can get like a cup or like a sheet of paper underneath it, and it nicely walks onto it, I will try and put it outside. But like I said, if it's going for my face, you are not... I'm sorry, spider, you're not getting a soft landing. And ad break is about to start. So I'm gonna go ahead and run the ad break, and then I'm gonna get ice while I'm doing that. Yeah, but like I said, if it's... But if I see it in my house and it hasn't crawled on me or anything like that, I still try and catch it and take it outside, so... The dark, spindly formations were spotted in the formation known as Incan City on Mars' southern polar region. Thanks! I don't think I could own spiders, mind you, because I would feel sorry for the worms that I'd have to feed them, or the crickets. Images taken by ESA's Mars Express Orbiter and ExoMars Trace Gas Orbiter show dark clusters of dots that appear to have teeny little legs, not unlike babies spiderlings huddling together. The formations are actually channels of gas measuring 0.03 to 0.6 miles, 45 meters to 1 kilometer across. Old world tarantulas. This is getting me vibes of, hey Haru, how's monster hunting coming along in Monster Hunter? I only saw your message about joining you on the hunts, like right before I started stream, so sorry. They originate when the weather starts to warm in the southern hemisphere during the Martian spring, melting layers of carbon dioxide ice. The warmth causes the lowest layers of ice to turn to gas, or sublimate. As the gas expands and rises, it explodes out of the overlying ice layers. The Geralt quest, that quest. I need to get myself in. Well, no, I'm not a bow user. I don't have to do that quest. But yeah, I want to see you play it. This dust geyser out of the ice before showering down on the top layer, creating the cracked, spidery pattern seen here. In some places, the geysers burst through the ice up to 3.3 meters, 3.3 feet, or 1 meter thick, according to the ESA. Incan City is also known as Augustus Labyrinths. It's named for its linear rune-like ridgelines, which were once thought to be some petrified sand dunes, or perhaps remnants of an ancient Martian glaciers. Oh yeah, it was the in-game stuff before the DLC kind of thing for before you did the add-on, the updated content to the original, where certain Koviteroth and stuff came along, but anyways, could be have left high walls of sediment behind as they retreated. In 2002, however, Mars Orbiter revealed that Incan City is part of a circular feature approximately 53 miles, 86 kilometers. This feature may be an old impact crater, suggesting that the geometric ridges may be magma intrusions that rose through the cracked, heated crust of Mars after it was hit by a renegade space rock. The crater would have then filled with sediment, which has since eroded, partially revealing the magma formation's reminiscence of ancient ruins. NASA reveals a giant lava lake on Jupiter's volcanic moon. Please not.
Picture the most volcanic hellscape in the solar system. And what you're picturing is Io, Jupiter's fiery volcanic moon. NASA has just revealed this. a gigantic lava lake. This animation is made using data from two extremely close flybys of Io made by the Juno spacecraft in December 2023 and February 2024. The lake is some 120
Nice background music.
kilometers long
Okay.
and called Loki
Very quiet.
Patera,
I'll start it
with
over again.
bizarre islands in the middle of this the most volcanic hellscape in the solar system. And what you're picturing is Io, Jupiter's fiery volcanic moon. NASA has just revealed this
Better?
gigantic lava lake. This animation is made using data from two extremely close flybys of Io made by the Juno spacecraft in December 2023 and February 2024. The lake is some 127 miles or 200 kilometers long and called Loki Patera, with bizarre islands in the middle of this strange magma lake, which is so smooth that it's reminiscent of volcanically created obsidian.
That's what I was thinking.
Io is the most volcanically active world in the entire solar system, home to about 400 active volcanoes, which spew lava and other volcanic materials up to 300 kilometers out into space. Not only that, but new research suggests that Io has been volcanically active since the birth of our solar system.
So Io never got a break?
The gas erupting out of Io's volcanoes is sulfur, and scientists use the fact that Io has lost between 94 and 99% of its original sulfur to work out that it's been spewing lava for about 4.57 billion years. As the closest of Jupiter's 4 Galilean moons, it's squeezed and squashed between Jupiter's humongous gravitational pull and that of the other moons, almost like a stress ball, causing it to heat up in the process and producing this uniquely volcanic world known as Io.
It occurred to me for a second on whether or not what would happen to it if it lost all of its silver. This looks interesting, but I'm doing the space stuff now, so I'm gonna leave it up. Okay, there's two different articles that is about this same subject, okay? So, they might be covering the same stuff, but done in a different way. I just wanted to show you, or show different stuff in the sense of more information and stuff. Anyways, astronomers find evidence of a massive object beyond the orbit of Neptune. Something gigantic appears to be stabilizing objects beyond the orbit of Neptune. A team of researchers say they found the strongest statistical evidence yet that Planet 9 is really out there because we got rid of Pluto. In the solar system, after studying a population, it used to be Planet X because 10. Studying a population of distant, unstable objects that cross Neptune's orbit. By the way, I'm okay with them getting rid of Pluto, by the way. Mainly because they found like a dwarf planet that's actually bigger than Pluto a little farther back out. So then we'd say it's a dwarf planet, it's not a planet. When it comes to discovering planets, finding them around other stars is actually a little easier than locating them around our own. Astronomers can watch for dips in light as planets pass their host stars and block the light reaching our telescopes on Earth or in space, known as the transit method. Well, I mean, it's better than what Disney's doing right now. Or by observing the wobble of star. Well, Disney's doing to all the characters in their roster. By observing the wobble of a star caused by planets orbiting it and the knock-on effect that it has. Through these methods and a few others, we have discovered thousands of exoplanets in the last few decades, while the number of planets in our solar system has remained at 8. Discovering planets around our own sun has relied on two methods: seeing them in the sky and observing slight disturbances in the orbits of other objects. Venus, Mercury, Saturn, Jupiter, and Mars were all found through visual sightings. Uranus was discovered in 1781 by astronomer William Herschel, after he noticed a bright object had moved compared to the other stars in a survey and took a closer look. Neptune was discovered when an astronomer and a mathematician, Urbain Le Verrier noted that Uranus's Neptune was different from the orbit predicted by Newtonian physics. He realized that this could be explained by another planet beyond Uranus affecting its orbit, and predicted where this planet would be. But our discovery of planets within the solar system may not be over yet. In 2015, two astronomers from Caltech presented evidence that 6 objects past the orbit of Neptune were bunched together in a way that suggested they were being herded by something with a large gravitational pull. Despite suggestions that the planet could be due to a statistical anomaly and selection bias, the team believes the objects could be moving due to an influence of a large object beyond Neptune's orbit. In a new paper, the team looked at a long period objects that crossed the path of Neptune's orbit, finding that their closest point of orbit to the Sun was about 15 to 30 astronomical units, AU, with 1 AU being the distance between the Sun and the Earth. Long study, we explored, in the new study we explored the opposite end. The most unstable long period, TNOs, I guess that's the circular movement, because it has the perihelion. By the way, let me. Perihelion is the point in which an orbiting body is closest to the Sun. The word comes from the Greek meaning peri. Near the solar system's plane, there are 17 such objects. And notably, their perihelion distribution is almost flat, between 15 to 30. Okay, TNO stands for Trans-Neptunian Objects, by the way. Long period TNOs, or their perihelion, is greater than 30 AUs near the solar system's plane, and there are 17 such objects with a less than 100 AUs, and notably their perihelion distribution is almost flat, between 15 to 30 AUs. Given their dynamic instability, only 2 scenarios can maintain this population of and TNOs in a steady state. They're either driven inward by interplay between the galactic tide and Neptune's scattering, or they result from dynamics introduced by Planet 9, shown in the figures. Major axis. Carrying out simulations to try and discover what best explains the orbits of these objects, the team found that a model that includes a massive planet beyond the region of Neptune explained the steady state of these objects much better than in simulations where 9 planets was not included. In the model, the team included other variables such as the galactic tide and gravitational influences of passing stars. We talked about this in one of the other episodes about how passing stars, like passing from our solar system that we wouldn't know about because they're so far away, but would still have effects on us. I wonder if that's the... Okay, influence of the galactic tidal field on the comet cloud. We examined the effect of the galactic disk, or tidal force from the disk produces a low draft of the comet's orbital angular momentum. This actually... Icarus. Sorry. Just noticed that was Icarus up there. I'm gonna stop. Stop! Stop! I'm gonna confuse myself more, I think, if I look at it. We carried out detailed calculations for both the P9 scenario and the galactic tide model. Results show that when Planet 9 produces a flat perihelion distribution of Neptune crossers mirrored in observation data, the model with without the P9 results in a distribution peak of around 30 AU. But what about observational bias? After adjusting for it, the data favored the Planet 9 model as at a striking 5 sigma level. Surprising this exotic group of TNOs proves the strongest statistical evidence that Planet 9 really is out there. Though this is intriguing, the analysis does not narrow down where to look for such a planet. Thankfully, we might not have too long to wait on that front. Excitingly, the dynamics described here, along with all the other lines of evidence for Planet 9, will soon face a rigorous test with the operational commencement of the Vera Rubin Observatory, the team concluded. This upcoming phase of exploration promises to provide critical insights into the mysteries of our solar system's outer reach. Alright, this is the independent on it. Like I said, I was getting 2 different views of it. Oh, it actually explains what Okay, I didn't have to look that up, but I guess it's fun. I'm not paying attention to that. Scientists say they found evidence that a hidden planet in our solar system. For years, some astronomers have been suggesting that an unusual behavior on the edge of our solar system is best explained by another undiscovered planet. That helps explain the orbits of objects that lie at the very far reaches of our solar system, more than 250 times away from the sun than we are. Now Konstantin Batyagin, an astronomer who's helped popularize the theory, says that he and his team have found yet more evidence that suggests the planet exists. The new work represents the strongest statistical evidence yet that Planet 9 is really out there. In the new work, scientists looked at a set of trans-Neptunian objects, or TNOs, which is a technical term for objects that sit outside the edge of the solar system beyond Neptune. The new work looked at those objects that have their momentum made unstable because they interact with the orbit of Neptune. That instability means that they were harder to understand, so typically astronomers looking at a possible Planet 9 have avoided using them in their analysis. Researchers instead looked towards those objects and tried to understand their movements. And Dr. Batyagin claimed the best explanation is that they result from another undiscovered planet. The team carried out a host of simulations to understand how those objects' orbits were affected by a variety of things, including the giant planets around them such as Neptune, the galactic tide that comes from the Milky Way, and passing stars. The best explanation from the model that included Planet 9, however, was from the model that included Planet 9. They noted that there were other explanations for the behavior of those objects, including the suggestion that other planets could once influence their orbit, but have since been removed, but claim that the theory of the Planet 9 remains the best explanation. And of course it says about the observatory coming online. We'll be able to tell them better. Alright, we get to talk about another forbidden planet. Sorry. Forbidden planet orbiting small star challenges gas giant formation theories. A team of astronomers led by Carnegie's Shobham Kandya has discovered an unusual planetary system in which a large I'm gonna keep calling it glass, am I? gas giant planet orbits a small red dwarf star called TO1-5205. I mean 5205. Their findings, which are published in the astronomical journal, challenges long-held ideas about planetary formation. Smaller and cooler than our sun, M dwarfs are the most common stars in our Milky Way galaxy. Due to their small size, these stars tend to be about half as hot as the sun and much redder. They have very low luminosities, but extremely long lifespans. Although red dwarfs host more planets on average than others, more massive type of stars, on average more... How's that written out? Although red dwarfs host more planets on average than other more massive type of stars, why are there so many... I like my commas. I absolutely love my commas. I use too much of them, as my English teacher has said before. There should not be that many commas. It says, although red dwarfs host more planets on average, there should not be a comma between on average. And there shouldn't be one here after average. There shouldn't be one after here other massive types of stars. And the only comma that should be here is the one right here. More massive types of stars. The reason why I kept on pausing during that was because how you read commas is you're supposed to pause after reading a comma for a few seconds before reading the next word. Hi Hara, how are you? Their formation history makes them unlikely candidates to host gas giants. The newly discovered planet TOI 5205b was first identified as a potential candidate by NASA's Transit Exoplanet Survey satellite. I'm sorry if I'm going to slaughter all these names, or at least some of them. Dia's team, which includes Carnegie's and Alan Boss, Johanna Teskey, and John Chambers, then confirmed its planetary nature and categorized it using a variety of ground-based instruments and facilities. The host star, TOI 5205, is just about 4 times the size of Jupiter, yet it has somehow managed to form a Jupiter-sized planet, which is quite surprising. Says Canodia, who specializes in studying these stars, which comprise nearly 3/4 of our galaxy, yet can't be seen with the naked eye. A small number of gas giants have been discovered orbiting older M dwarf stars, but until now, no gas giant has been found in a planetary system around a low-mass M dwarf like TOI 5205. To grasp this comparison here, a Jupiter-like planet orbiting a Sun-like star could be compared to a pea going around a grapefruit. For TOI 5205b, because the host star is so much smaller, it's more like a pea going around a lemon. Yeah, that's cute. Yeah, no. In fact, when the Jupiter mass TOI 5205b crosses in front of its OS, it blocks out about 7% of its light. One of the largest known exoplanet transits. Planets are born in rotating disks of glass. I'm back to calling it glass. Of gas and dust that surrounds young stars. The most commonly used theory of gas planet formation requires about 10 Earth masses of this rocky material to accumulate and form a massive rocky core, after which it rapidly sweeps up large amounts of gas from the neighboring regions of the disk to form the giant planet we see today. The time in which this happens is crucial. TOI 5205b's existence stretches what we know about disks in which these planets are born. In the beginning, if there isn't enough rocky material in the disk to form the initial core, then one cannot form a gas giant planet. And at the end, if the disk evaporates away before the massive core is formed, then one cannot form a gas giant planet. And yet TOI 5205b formed despite these guardrails. Based on our nominal current understanding of planet formation, TOI-5205b should not exist. It is a forbidden planet. The team demonstrated that the planet's very large transit depth makes it extremely conductive for future observations with recently launched, of course, the telescope, Webb telescope, which could shed some light on its atmosphere and offer some additional clues about the mysterious formation. The test follow-up research was conducted using the Habitable Zone Planet Finder, the low-resolution spectrograph, the 10M Hobby Elberly telescope, the Antarctic camera. Okay, it just lists off all of them. Remember how I was talking about how we stopped being able to talk to Voyager? Why don't I try this one first? By the way, it took April 5th was when they figured out why Voyager 1 was having the problems, and we didn't hear back until the 22nd of this month, so a good amount of time, you know? I think. For the past 5 months, Voyager 1 spacecraft has been sending a steady stream of unreadable gibberish back to Earth. Now NASA engineers finally know why. The 46-year-old spacecraft sends regular radio signals as it drifts further from our solar system, but in November 2023, the signal suddenly became garbled, meaning scientists were unable to read any of its data. And they were left mystified about the fault's origins. In March, NASA engineers sent a command prompt, or poke, to the craft to get a readout from its flight data subsystem, which packages Voyager 1's science and engineering data before beaming it back to Earth. After decoding the spacecraft's response, the engineers have found a source of the problem. The FDS's memory has been corrupted. The team suspects that a small chip responsible for storing part of the affected portion of the FDS memory isn't working. NASA said in a blog post Wednesday, March 13th, engineers can't determine with a certainty what caused the issue. Two possibilities are that the chip may have been hit by an energetic particle from space, or it simply may have worn out after 46 years. Although it may take several months, the engineers say they can find a workaround to run the FDS without fried chip, restoring the spacecraft's messaging output and enabling it to continue to send readable data from outside our solar system. Launched in 1977, Voyager 1 zipped past Saturn and Jupiter in 1979 and 80 before flying out into interstellar space in 2012. It is now recording the conditions outside the sun's protective magnetic field, or heliosphere, which blankets our solar system. Voyager 1 is currently more than 15 billion miles, or 24 billion kilometers from Earth. And it takes about 22.5 hours for any radio signal to travel from the craft to our planet. And so the update now is at April 22nd. For the first time in 5 months, NASA engineers have received decipherable data from Voyager 1 after crafting a creative solution to fix a communication problem aboard humanity's most distant spacecraft in the cosmos. Voyager 1 is currently about 15 billion miles, 24 billion kilometers away, and at 46 years old, the probe has shown multiple quirks and signs of aging in recent years. The latest issue experienced by Voyager 1 first cropped up in November 2023, when the flight data system's telemetry module unit began sending back an undecipherable repeating pattern of code. Voyager 1's flight data system collects information from the spacecraft's science instruments and bundles it with engineering data that reflects its current health status. Mission Control on Earth receives that data in binary codes. Fun! Or a series of ones and zeros. But since November, Voyager 1's flight data system has been stuck in a loop. While the probe has continued to relay a steady radio signal to its mission control team on Earth over the past few months, the signal did not carry any usable data. The mission team received the first coherent data about the health and status of Voyager 1's engineering system on April 20th. While the team is still reviewing the information, everything they've seen so far suggests Voyager 1 is healthy and operating properly. Today was a great day for Voyager 1, Linda Spickler, Voyager project scientists at JPL, said in a statement Saturday. We're back in communication with the spacecraft, and we look forward to getting science data back. The breakthrough came as a result of a clever bit of trial and error, and the unraveling of a mystery that led the team to a single chip. Troubleshooting from billions of miles away. After discovering the issue, the mission team attempted sending commands to restart the spacecraft's computer system and learn more about the underlying cause of the problem. The team sent a command called poke to Voyager 1 on March 1st to get the flight data system to run different software sequences in hopes of finding what was causing the glitch. On March 3rd, the team noted that the activity from one part of the flight data system stood out from the rest of the garbled data. While the signal wasn't in the format the Voyager team used to seeing when the flight data system is functioning as expected, an engineer with NASA's Deep Space Network was able to decode it. The Deep Space Network is a system of radio antennae on Earth that help the agency communicate with Voyager probes and other spacecraft exploring our solar system. The decoded signal included a readout for the entire flight system's data. Goodness, I am becoming tongue-tied. The decoded signal included a readout of the entire flight data system's memory. By investigating the readout, the team determined the cause of the issue. 3% of the flight data system's memory is corrupted. A single chip responsible for storing part of the system's memory, including some of the computer's software code, isn't working properly. While the cause of the chip's failure is unknown, it could be worn out or maybe have been hit by energetic particle from space, the team said. The loss of the code on the chip caused Voyager 1's science and engineering data to be unusable. Since there was no way to repair the chip, the team opted to store the affected code from the chip elsewhere in the system's memory. While they couldn't pinpoint a location large enough to hold all the code, they were able to divide the code into sections and store it in different parts within the flight data system. To make this plan work, they also needed to adjust those code sections to ensure, for example, that they still functioned as a whole. According to, I bet you love hearing this about this, Haru, an update from NASA. Any references to the location of that code in other parts of the flight data system memory needed to be updated as well. After determining the code necessary for packaging Voyager 1's engineering data, engineers sent a radio signal to the probe commanding the code to a new function in the system's memory on April 18th. Given Voyager 1's immense distance from Earth... Yeah, they need your help. Hey, look, Haru! There is a use! I'm teasing. There is a use for programmers. What is this? Hardy har har. Given Voyager 1's immense distance from the Earth, it takes a radio signal about 22.5 hours to reach the probe, and another 22.5 hours for a response signal from the spacecraft to reach Earth. On April 20th, the team received Voyager 1's response, indicating that the clever code modification had worked, and they could finally receive readable engineering data from the probe once more. With the system, within the coming weeks, the team will continue to relocate other affected parts of the system software, including those responsible for returning the valuable science data Voyager 1 is collecting. Initially designed to last 5 years, Voyager 1 and its twin, Voyager 2, launched in 1977 and are the longest operating spacecraft in history. Their exceptionally long lifespans means that both spacecraft have provided additional insights about our solar system and beyond after achieving their preliminary goals of flying by Jupiter, Saturn, Uranus, and Neptune decades ago. We talked about the Voyager 1 couldn't communicate with Voyager 2 until about August, because they basically shouted at it to get its spacecraft antennae back in the correct direction. The probes are currently venturing through uncharted cosmic territory along the outer reaches of the solar system. Both are in interstellar space and are the only spacecraft to ever operate beyond the heliosphere, the sun's bubble magnetic of magnetic fields and particles that extend well beyond the orbit of Pluto. Voyager is currently at 12.6 billion miles, or 20.3 billion kilometers from our planet. The team estimates is a few weeks away from receiving science data from Voyager 1 and looks forward to seeing what that data contains.